All right, welcome everybody to today's demo on the MaxDCont output option in the AirMod model. Today we're going to talk about what this option does for you in running the AirMod model, how you would set it up, and we're going to go over an example in each of that setup. And then I'm going to talk about briefly at the end about the MaxDCont Viewer that helps you view output files created by this option, and I will also do a quick demo of that program. Now the option itself applies to three pollutants that you're modeling. It applies to 1 hour NO2, 1 hour CO2 modeling, and 24-hour PM2.5 modeling. And before I get into the option, I just want to go over those standards quickly. So for 1 hour NO2, the standard says that it's the 3-year average of the 90th percentile of the annual daily maximum values. So you're going to average values over multiple years, and you're going to calculate the 90th percentile or the 8th highest value for each receptor. And actually, in the current version, AirMod will do this for you, as long as you set up the model properly, which we'll go over a little bit later in this demo. The standard is 100 parts per billion, or 188 micrograms per cubic meter. Similarly, the SO2 standard is based on the 99th percentile, which is also averaged over multiple years, as well as 3 years or 5 years of National Weather Service met data. And that standard is 195 micrograms. And then for PM2.5, it's the daily average, not the hourly average. But it's also based on 98th percentile, which is the first high value for that one, and it's 35 micrograms. So the MaxDCont option applies to these three modeling scenarios again: 1 hour NO2, 1 hour CO2, and 24-hour PM2.5. All right, so this option was introduced back in 2011 in AirMod version 11.059, and what it's used for is to determine the contributions of each source group that you've set up, the hiring values of a target source group. And what that means is that if you have sources from your projects in the model, as well as sources from other nearby facilities, what you can do is calculate the concentrations for all of those sources combined, and then figure out the contributions from your project sources versus another facility's sources to that high value. And actually, the way that it works is that you actually should analyze contributions not just to the highest value, such as the 8th highest for NO2, but to all cases where the standard is exceeded. So all values such as, let's say, for SO2 would be the 4th highest, 5th highest, and so on. As long as your concentrations are above the standard, this option will tell you what the high concentrations are and what the contributions from each source or source group are. And on the previous slide, when we talked about hiring values, what we're talking about, I think, is just the high value, such as the 4th high or the 5th high. Upper rank to lower rank are the high values that produce high or low concentrations respectively. And threshold is the concentration where you should stop analyzing the contributions. We'll see this a little bit later in the model setup section. So actually, to set up these model runs with the MaxDCont option, you need to set up three things. And in the example model that I'll show you today in Beast, we're going to be focusing on the SO2. So first of all, you need to select the averaging period. It should be 1 hour for M2 SO2, 24 hours for PM2.5. So let's go to control options and CO options. For SO2, it's just the 1 hour, nothing else. Then the pollutant has to be SO2. For NO2, the pollutant has to be NO2, and for PM2.5 has to be either PM2.5 or PM2.5. Okay, so we have that set up now. It's SO2, 1 hour, no other averaging periods. Then you also have to define your source groups, such as all for all of your sources and possibly projects for just sources in your project. And that's done in source options and source groups. Now in this example model, what we actually have is two facilities. One of them is our sources, the other is sources from another facility. And several source groups have been set up in this example. There's the all group, which is concentrations for everything. And you have the project group, which is just our project. And actually, that would be which is just the three sources here within this fence line. And if the other source groups have been set up as well. So what we can do is with this MaxDCont, we can find out the overall concentration of SO2, as well as how much of that comes out of our project sources. So this is the second step, going to source groups and defining an all source group, as well as a project source group, or multiple groups, as in this case. The next step, we need to set up our output options. Now, normally if you just model, let's say SO2, you just model the fourth high there. However, for the MaxDCont option, we're going to recommend having AirMod calculate additional high values as well, even after the 300 high, which may be more than me, but that will make sure we get all the high values where the standard is exceeded in our output. So that's done is in output options where you would normally, and again this is for SO2 in our example, you normally just click the fourth highest, but what we're going to do is just say 4-300 in the range here. So it'll give us fourth high, fifth high, sixth high, and so on, all the way to 300. Like here, if you know that your overall concentration is not going to be much higher than the standard, which is 195 for SO2, you're going to say 4-100 and save yourself a little bit of runtime. Then after that, we finally go to this MaxDCont tab and tell it the things need to generate an extra output file called the MaxDCont file, and that's the file that will give us all the contributions to our high values. So in a normal SO2 modeling, so we'll just select the fourth high, but here select a range, and then we go ahead and go to this new MaxDCont file tab. Now there are a few settings that we need to take a look here. First is the source group, and we selected all, so calculating the contributions of everything else to the all source group. That's what we generally do. Parentheses is 4, which is the fourth highest. And in this case, I choose to put in the threshold value of 196, which is the standard. So what will happen is that, in addition to calculating the fourth highest value, AirMod will go ahead and continue to calculate all the high concentrations for fourth highest, fifth highest, etc., until there are no receptors with a value above 196. And then it'll put all the information into this one file, which is the MaxDCont output file. Now, what I could have also done is said, calculate everything between the fourth high and, let's say, the 100th high, or 300th high. In that case, I would not use the threshold value option. It has to be one or the other. And with that, the AirMod setup is done. The model setup is done, and now you would run AirMod as usual. And that's already been done in this modeling example. Second, going back to the output options, we enter multiple high values here to make sure that our output contains all cases where a concentration is above the standard, which might be not just at the fourth high, but at the fifth high, sixth high, etc. Okay, here I have a screenshot of that MaxDCont file selection that I just showed to you. And this file has to be specified for the MaxDCont output option to work. You can't omit it. So now after the model is run, it creates an output file that you can view either by hand or with our new tool called MaxDCont Viewer. And before we can still need to show you what that file looks like. Or it looks like a normal output file, but then also we have is at each and every receptor we get the high concentration value, and then for cases where that value is above the standard, such as 595 value, we have additional columns that says at that receptor and at that time and date, that receptor, what are the concentrations of each of our source groups? So we go down to this value with 595 in it. We can see the various concentrations, and it looks like the highest one comes from the group called, let's go up a little bit. I'm saying now it's the project. Okay, it shows you concentrations at the same time from each of our source groups. So there's project and my sources and so on. But instead of looking at this file manually, you can now use the tool called MaxDCont Viewer, where you can view the high concentrations and contributions graphically, and you can also select a source group to view the contributions for just that source group. I'm going to go ahead and open this tool here. Now I'm going to do is say open the BCTA file, and what that will do is that will open the input file for our model run that we just did. Well, actually, that was done a while ago. Now you're asked to which MaxDCont output file do you want to view. In this case, there was only one, so it's selected by default. Now I can just click OK. And when I zoom in, here's what I'm going to see. So here are the receptors. First of all, at the bottom here, you see the threshold is 196. So it's only going to show you right now. It's only going to show you the values where the concentration exceeds that standard. So the standard, which is just a few receptors. So at the fourth high value is when the exceedance occurred. And I can actually go down and select the fourth high, fifth high, etc., and see the high values at those receptors for those such as for the sixth high. At this receptor, it's actually 348 is the concentration. And the other thing that I can do is also say that, let's say at the fourth high concentration, I say what is the contribution of the project group. If I select the group, the display will be updated to show you that it's less than 1 microgram per cubic meter. So this is after for this high value, our contribution is less than 1 microgram, and the highest one actually is here is 0.41 at this receptor. So what the tool allows you to do is go through the high concentrations such as the fourth high, fifth high, and so on, and see what are the contributions from each individual source group in your model. And the National Air Quality Limit Standards also define something called the significant impact level, which says whether your project contributions are significant, whether your project causes a significant impact for an exceedance. So we're going to force to do that 7.8. And you can see none of the concentrations from our project are 7.8 or higher. So that means that in this case, the exceedances are caused by some other nearby facility or some other sources, not our project sources. And you can even see our project's contributions to the exceedance really quickly with this tool. With this tool, and you can quickly determine whether our project causes exceedance or whether something else is contributing that exceedance. So I can just repeat in the model 7, you will need to set up this additional output file called MaxDCont output file. And then you'll be able to review the results in this new tool called MaxDCont Viewer. And one other thing that this tool allows you to do is to filter results as well. You can go back to group all here. And if you click the options button on the top left side, you can tell it that you don't want to see any concentrations below the value, let's say 50. You then say OK, then all the values below that will be hidden, and you can just see the high values in the on the display. And finally, the MaxDCont Viewer tool allows you to export what's on the right side to a file so that you can include an image in your presentation. With that, you just say save graphic to a file, give it a name, and then you can open the file and view it. So that's the presentation on the MaxDCont option. Thank you for watching our presentation. I will go ahead and now take questions.